Good day. Welcome to another live class session for mathematics. Now, in our earlier sessions, we have been looking at a lot of concepts. We have looked at concepts around indices, logarithms. We also looked at concepts around modular arithmetic, as well as binary operations. We also talked about the various different values or different functions or different laws, rules, or properties, however you decide to call it, that guide those concepts and how we use them. For today's session, we are going to be looking at the concept of variation. We are looking at the concept of variation. Now, for variation, we are going to be looking at the different variations, if I can use that word, the different variations that can exist under it, right? There are different types and different concepts attached to variations, and we'll be looking at all of this in detail. We will begin from simple and look at the simplest form of variations, and then move to the complex forms of variations that you will find in your exams. Of course, all these forms of variations will still exist as simple, clear ways in which you can easily solve those questions, regardless of any of those questions it might be, as well as how you can use those solved values to evaluate your answer in the quickest, efficient way possible. So let's get to it. Now, in order to get a very clear view of what we term as variation, as well as what we need to know as variation, the very first thing is that we must first and foremost have a very good grasp of what we term subject of formula. In this case, it means that we must be able to isolate a single concept or a single variable within a list of variables, and then use that isolated variable to get the value with respect to all the others, which will now be dependent, or which will now be the independent part of the variables. Remember that you are always familiar that if we say y is equal to f of x, then we are simply saying that x is in fact the independent variable, and then y is in fact the dependent variable. This concept is the concept that guides variations. So because we are simply saying that one single variable is varying in quantity or in quality or in its worth with respect to other variables. So one of those variables that has been isolated serves as the dependent variable that is now written in terms of the other independent variables. So it's very, very important for us to be able to write subject formulas, and they can come in different forms. For instance, of course, we know that a simple formula, we can find the circumference of a circle as 2 pi r. If we decide, for instance, to make r the subject of the formula, then all we just simply have to do is divide both sides by 2 pi, and then we'll have that r will be equal to c divided by 2 pi. In this case, what have we gotten? We have gotten r as the dependent variable, and then we have gotten all of this as the independent variable, which means that r, the value of r, will depend hugely on whatever all these values are. This concept is what guides the concept of variation. So let's look at simple functions and determine the subject of formulas of those functions before we go into our job for today. So first off, let us attempt this. We'll start from simple. Let us solve for p in p minus 7 is equal to 24. Now, if we have p minus 7 is equal to 24, let us solve for p there. We will simply mean, so we have solution, p minus 7 is equal to 24. Our goal is to isolate p, so it means that we have to get rid of this minus 7. So if we add 7 to both sides, we are simply going to have that p is equal to 31. Simple and short. We have made p subject of the formula. So in this case, you can easily say that we are evaluating p. Let's look at something else. Let's look at something much more interesting. Let's have 5 into c plus 2 minus 3 into 3c minus 5 is equal to 1. So when we even talk about solving for a particular variable, we are just making that variable subject to formula still. So we are solving for c. Now, how do we do this? Of course, we can first and foremost rewrite the line so we have a clear path as to what exactly we are seeking to get. Then at this point, we can simply expand. So we have 5c plus 10 minus 9c plus 15 is equal to 1. And then collect like terms. So 5c minus 9c, we have minus 4c plus 25 is equal to 1. Bring this to the other side, becomes negative. Minus 4c is equal to 1 minus 25, which will give us minus 24. So dividing all two by minus 4, we'll have that c is equal to 6. So we evaluated for c, but in essence, we also made c subject of the formula. Now let's look at values in which we can't easily just identify, or we can't easily just find the values like this. Let us make n subject of the formula in t is equal to a plus n minus 1 d. Now, what do? We can simply expand. So we are making n is our focus. We must not forget that. We have that t is equal to a plus nd minus d, because 1 times d will still give us d. Then we can send every other thing to the other side, which means that our priority now is on n. So this is the only one we want to remain. The others will send. We now have that nd is equal to t remains minus a plus d. Right? Once this one crosses, it becomes negative. Once this one crosses, it becomes positive. Next, we now divide all through by d, because our focus is to get n alone. So n will now be equal to t minus a plus d divided by d. So we have made n subject of the formula. So you see that, of course, if we had values take the place of t, a, and d, then n will obviously evaluate into a value. But it doesn't always happen like that. Whenever we use subject of the formula, it means that our goal is to find a generalization for that particular variable, so that we can write that variable as a value that satisfies a function of the other independent variables. Independent because you see that on this right-hand side, there is no longer an n value here. All the n values that are dependent have been brought to the left-hand side. What we have here are just the values that are independent of n. That's why we call them independent variables. Now that we have looked at that, let's look at something much more interesting. Our fourth example on subject of the formula, let's make G subject of the formula. So this is the formula here. T is equal to 2 pi square root of L over G. T is equal to 2 pi square root of L over G. So this is a very important and popular formula as far as physics is concerned. But we are just going to simply use this formula on its basic identity. Now our goal is to get G. So every single thing we are going to do, we are doing it with the aim of isolating G. Now we will not get anywhere if we cannot take the square root of G. But then we'll see that this square root is multiplying 2 pi. So we can first and foremost say, okay, let us write it as T divided by 2 pi is equal to the square root of L over G. Yes, we have just divided both sides by 2 pi. No harm done. Now, let us square all sides, or square both sides. We would now have square root of L over G, all squared. Now, do not forget that by law of indices that we have looked at, the square root simply refers to what? A fractional power of 1 over 2. So it means that we would have here t squared divided by 4 pi squared would now be equal to what? L over G, because 1 over 2 would obviously cancel out the 2, which is the square. If you have issues seeing it, let me write this square root as 1 over 2 and then put in a square outside. So you see that it cancels out. That's not a problem. So you will have it as t squared divided by 4 pi squared is equal to L divided by G. Now, again, we are meant to isolate G. So at this point, we can cross multiply. So if we cross multiply, what do we have? We would have gt squared is equal to 4 pi squared L. and then dividing through by t squared because you need to isolate g. Now have that g is equal to 4 pi squared L divided by t squared. And we have simply made g subject of the formula. So you see that sometimes the subject of the formula would look a little bit simple, sometimes it might look a little bit absurd, but then the process is always the same. So long as we are able to bring out that variable and isolate it on one side of the equation, then we have completed subject of the formula. Now it's very, very important to know how to do this, because the next branch we are going to, which is in fact what variation is, we will need to be able to isolate various variables as the case might be, and then look at how exactly we plan to solve for those variables. Now that we have looked at solving the formula, let's now go into our course for today in detail. We are looking at variations. Now, before we even go into the different branches or different types of variations we have, let's talk about the basic way variation works. Now, variation works first and foremost with the use of a variation symbol, right? A variation symbol. And of course, we can simply just stamp this as variation symbol. The Greek name for this is the alpha. Now, our goal is to always denote or replace this variation symbol with what we can calculate with. And what can we calculate with? The equal to sign. The moment the variation symbol transcends into an equal to, then we introduce a constant of variation. Constant of variation. If you call it variation, is fine. If you call it proportions, is fine. Constant of variation or constant of proportionality, that's fine as well. Either one works in this case. Now, we start first with the variation symbol. Our goal is to transform that variation symbol into the equal to. Transforming it into the equal to introduces the constant of variation, which you have to calculate for. This is the general process all our variations will go into. Now, let us now begin first and foremost with our types of variation and see how each type determines how we carry out our variation itself. Now, for the first type of variation we'll be picking the direct variation. The direct variation. Now, when we say direct variation, what exactly are we talking about? In broad details, in the blankest form. A direct variation is a variation between two variables such that an increase in the first variable tallies into an increase in the second variable. A decrease in the first variable tallies into a decrease in the second variable. So it's an increase system or a decrease system, right? So whatever happens on the first side must happen on the second side. Whatever happens on the first side in positive nature must be in the positive nature on the second side. If it's in negative nature, it must also be in a negative nature in the second side as well. So for instance, if you were to denote it in a graph, you will simply say something like this. The values would increase. So you go upwards. So as A increases on this line, on this horizontal line, B must also increase on this vertical line. Of course, it doesn't matter if they are increasing at the same pace, but they must both increase. There cannot be a situation where there is an increase in the first variable and it is causing a decrease in the second variable. That's not possible. That is what direct variation stands for. Now, how do we now rate it? How do we say it? We say that X is directly proportional to Y, or you say X varies directly as Y, or you say X is proportional to Y. So if you say X is proportional to Y without putting the direct there, then it still means direct proportional by conversational thinking. So is that you say X is directly proportional to Y, or x varies directly to y, either way you say it works perfectly. Now, what does this denote? This denotes that you are saying that x is directly proportional to y, right? An increase scenario. Now, if this is the case, the moment we decide to change the variation symbol into equal to, we have x will now be equal to ky, where k is our constant of variation. X is equal to ky. Simple and short. That is all we are going to be doing as far as direct variation is concerned. Application of this. Of course, how do we now calculate? Our first step whenever we are calculating this is generate the function. We will not get anywhere if we cannot generate this function. Once you have generated the function, solve for k. We need that constant of variation. Now, why is that constant of variation important? Because, of course, we said an increase in the first value can cause an increase in the second value, which means that the values can change anyhow they like. So long as if this one changes from 10 to 50, this one is also changing from, let's say, 20 to 100, it's direct variation. Now, how do we keep track of all those changing values? What makes us able to keep track of all those changing values is the presence of k, which is the constant of variation. So it means that the very first thing is we must find what k is. The moment we now find k, then we can now proceed to answer the question. So the question can either be finding what y would be at a particular point of x, or finding what x would be at a particular point of y, as the case might be. But the major thing that will put you right on track into developing all those is generating the function, finding the constant, and then using it to answer the question. Now, at this point, we can now proceed to take examples on them. But to ensure that we are having a broad and holistic knowledge on it, let's first and foremost define all the variations we'll be using, so that at least to a great extent, when we begin to take questions, we can now properly discern that, okay, this is a question that will work for direct variation, this is what we'll use another kind of variation for, and so on and so forth. So just as we have explained the direct variation, let us move on to explain another kind or type of variation. Now, for the other kind of variation we'll be picking, let us pick the inverse variation. Yes. Now, for the inverse variation, what are we talking about? The name inverse. What it simply means is that if there's an increase in the first variable, it must correspond to a decrease in the second variable. A decrease in the first variable must also correspond to an increase in the second variable. So in this case, it's an increase-decrease scenario or a decrease-increase scenario. That is how inverse variation works. If you were to plot a graph for it, we are simply saying that if this is going this way, this must come this way. So it means that you are talking about the fact that whenever this is at the lowest point, that is when this is at the highest point. And whenever this is at this lowest point, that's when this is at the highest point. So you are talking about the variation that goes like this. Something like that. So as this increases in value, this will decrease in value. If this increases in value, this will decrease in value. That is what an inverse variation does. Now, how do we write it? We can simply say that x is inversely proportional to y, or we say that x varies inversely as y. And how do we write it? We write it as x. Remember that it's an increase-decrease scenario. So it means that whatever happens to x will create a reciprocal effect on y. Reciprocal effect. Look at the difference. Equal effect, reciprocal effect, inverse. So we will have this as what? X is now going to be equal to k over y, or k times 1 over y, either way you decide to call it. So this is not so strange because it's inverse. So it means I'm saying that x goes to y inverse, basically. And by law of indices, y inverse will give you 1 over y. So you are good to go. So the same process still holds. I must be able to, for any question given to me, generate the function, find or determine the value of y, and then use that to solve the question. That is very, very important. All these values are very, very important. Direct variation is an increase variation. Inverse variation is an decrease variation, and so on and so forth. Now that we have looked at this, we still have much more types of variables of variations to look at. Let's delve into them. Of course, if we were to put it so simply, we can easily say that direct and inverse variations are variations that are closely related, in the sense that this is just saying that it's an increase. This is saying it's an decrease, right? So this is just possibly you saying the opposite of this, right? If this is flowing in the same direction, then this is saying, okay, I want to flow in the different direction, just as the maps have shown. So at this point, let's pick these two, which are closely similar, and solve questions on them and see exactly what we have. So now let's pick our first example. If y varies directly as x, find the constant of variation. Find the constant of variation when y is equal to 12 and x is equal to 4. So let me give you a minute to look at the question. First, your goal is identify what kind of variation you are dealing with and see if you can write out the equation. We will then solve it together, right? So just take some 30 seconds to look at it briefly and let's know what exactly you have. Great, I'm sure you'd have had some 1 or 2s to write. Let's see how to solve this together. Now, if y varies directly as x, this is the very first part of the sentence we need. If y varies directly as x, varies directly is telling us this is a direct variation. So we are saying that y must vary directly as x. Now the order is very, very important. Do not change it. If you say y is varying directly as x, leave it as y coming first and x coming last. Do not be tempted to rewrite this as x directly to y. Of course, it might seem to not change a lot, but notations are very, very important. So take note of that. So if y varies directly to x, you have to find the constant of variation when y is equal to 12 and x equal to 4. So first, let us convert this into the equal to sign. We have that y will now be equal to kx. If that is the case, what do we now have? We'll have that we are looking for the constant of variation, which is k. So it means that we can proceed by making k sub of the formula. So if we make k sub of the formula here, what would we have? We'll simply have that k will be equal to y over x, dividing both sides by x. Now, we are looking for k when y is equal to 12 and x is equal to 4. What would that mean? That would mean that k would be equal to 12 over 4 because y is now 12, x is now 4, which will now mean that k will be equal to 3. So it means that the constant of variation in this case is 3. And you can test it out that it satisfies everything. If the values here are y equal to 12 and x equal to